In this video, let's see the effect of dielectric on capacitance, charge, electric potential, electric field, and the electrostatic energy stored in the capacitor. There are two cases. Case 1, battery is disconnected from the capacitor and then dielectric is inserted. And in case 2, battery remains connected and the dielectric is inserted between the plates. In this video, we'll see the case 1. So case 1, there's a capacitor of a capacitance C naught, which is connected to a battery of a potential V naught. And then after charging, it stores the charge Q naught. The distance between the plates is D. Now there is a relation between all the three parameters C0, V0, Q0. So what are they? So C0, the capacitance is actually defined as Q0 divided by V0. There's a relation between electric potential and electric field, that is V0 equals E0 D. And the electrostatic potential energy which is stored in this capacitance is U0 half Q0 squared divided by C0. Now let's see how these parameters changes when you insert a dielectric inside this. So you have the dielectric inside this. So start from electric field. So this capacitor is charged and the battery is removed for the case 1. And now dielectric is inserted. As soon as dielectric is inserted, there will be a dielectric polarization, which means that the positive plate here attracts all the negative charges there. So it induces this negative charge on this side, and opposite side there will be positive charges. So which means that there is a this is the original electric field in the capacitance, but here there will be an opposite electric field developed inside the dielectric field. So which means that the original electric field is reduced by the dielectric medium. Okay, so how much it is reduced? So this is the electric field after inserting the dielectric, and this is the electric field before that divided by K. K is the dielectric constant. So from here what can we conclude? E is less than E0. Electric field decreases. Now next one. Next one is here 2 electric potential. Go in this order, it will be easy to remember also, and it makes sense. So electric potential. Now electric potential and electric field has a relation V equals E D. Okay, so here this E is now E0 by K. Okay, that we are going to substitute it here. So V equals E0 by K times D, which means that this is actually V0. Okay, so we can write this as V0 divided by K, which means V is also less than V0. This also decreases. Now next one is capacitance. So according to the definition, capacitance C equals Q divided by V. So instead of Q, I'm going to write Q itself and Q naught itself, because the charge doesn't change after removing the battery. The charge stored in the capacitor is constant. So it will be Q0 only, divided by V. Instead of V, I'm going to substitute this. That is V0 divided by K. So K goes up. So this can be written as C0. That is Q0 by V0 is C0 and then K, which means that the capacitance increases after inserting the dielectric. Now the fourth one, that is the energy stored in the capacitor. So we know the formula U equals half Q0 or Q, whatever it is, because the charge remains same after inserting the dielectric, divided by C. So now instead of C, I have to write C0K from here. So now if you see, U is equal to U0 divided by K, because this will become U0 and then divided by K will be there. So U0 divided by K, which means that the energy actually decreases. This decreases. The capacitance increases. That's it. Let's see case 2 in the next video.